I thought it would be good for this review session of bone marrow to start off with this diagram of bone marrow showing the various cells that are found in it and the various structures that are found in bone marrow. Bone marrow has a lot of reticular cells in it, and these form a meshwork, and there are also reticular fibers which are secreted by these reticular cells. These reticular cells have specific glycoproteins on them, and these interact with various integrins on the surface of the various types of blood cells and bind them in niches during their division and maturation. So that as you look at our slide of bone marrow, you will see that in one area there'd be a lot of neutrophils, in another area there'd be a lot of red blood cells, in another area there'd be a lot of eosinophils. There are also large numbers of sinusoidal capillaries or venous sinuses running through the bone marrow, and these are lined with endothelial cells, and these endothelial cells have spaces in between them. The lumen is larger than a normal capillary, and blood cells enter these sinusoidal capillaries through these spaces between the endothelial cells and then find their way to the general circulation. Don't forget that in addition to neutrophil cell line developing and the red blood cell line developing in red bone marrow, which we'll be looking at, there are the eosinophil cell line, the monocyte cell line, the lymphocyte cell line, all developing in red bone marrow. And red bone marrow also has a lot of macrophages in it, which have the job of engulfing old red blood cells and destroying them. Now there are at least 8 cell types undergoing hematopoiesis in red bone marrow. The 5 types of leukocytes, 6 if you count B leukocytes and T lymphocytes, the erythrocyte and the megakaryocytes, which give rise to platelets. Now, if you can understand this diagram, I think you'll have a fairly easy time completing the assignment 4, as well as answering questions that might crop up on your exam. The terminology for stem cells is, to say the least, somewhat confusing and confused. So although I've got different terminology here to that which was present in this diagram, it doesn't matter which one you use if you are asked to answer such a question in the exam. A stem cell is a stem cell for a couple of reasons. One, it can give rise to a number of different cells or tissues further down the line. And secondly, it can undergo asymmetric division. An asymmetric division means that, for instance, when this multipotent stem cell is asked to divide, it will divide to give rise to, say, a myeloid stem cell and another copy of itself, rather than 2 copies of a myeloid stem cell. And that is true all down the line. As long as the cell is classified as a stem cell, if this myeloid stem cell is asked to produce more erythrocytes, it will divide under the influence of colony stimulating factors, and it will give rise to a progenitor cell and to another copy of itself. And this progenitor cell, which is still a stem cell, although it's now down at a unipotent stem cell stage, it can only go in this direction. If it's asked to divide, it will give rise to the next stem cell or the next cell. This is no longer a stem cell down the line, and to another copy of itself. So stem cells are stem cells for those 2 reasons. One, they can give rise to a variety of other cells or tissues further down the line, and they undergo asymmetric division. So I would like you to know for the exam the difference between a pluripotent or multipotent stem cell and an oligopotent stem cell. Pluripotent stem cell can give rise to all the cells that are produced in bone marrow. Oligopotent stem cells are restricted. The myeloid line can give rise to the red blood cell line, to the megakaryocyte line, and to the granulocyte line, whereas the lymphoid stem cell can only give rise to the B and T lymphocytes. When we get down to the progenitor cells, which are unipotent, they are now committed to producing just one cell type. The progenitor cell for the erythroblasts is committed to producing erythrocytes, ditto for the progenitor cell that gives rise to megakaryocytes, and ditto in a way for the progenitor cell that will give rise to all of the granulocytes. I say in a way because this is a fairly confusing lineage here. One would suggest that this oligopotent stem cell, and it is oligopotent because it can give rise to myoblasts and monoblasts, but then where do we fit the promyelocyte in here? It can give rise to all three different cell types. Should we call it an oligopotent cell, or is it just called a promyelocyte? And this is not well answered, so although I'm carrying on about this, I won't expect you to distinguish between the promyelocyte being a progenitor cell or being an oligopotent stem cell. Just know what is shown in this diagram. All of the precursor cells, progenitor cells, above these red lines are capable of dividing. As shown on the left-hand chart here, the potentiality of these various cells changes as one moves down the lineage. For instance, stem cells, such as this multipotent and these oligopotent stem cells, have a very high potentiality, but that decreases once they get into the progenitor cell area. And precursor cells, even though they're capable of dividing, are no longer capable of giving rise to an earlier form of the lineage to which they are committed. Their self-renewing capacity, as I talked about, this asymmetric division drops off dramatically once one gets away from stem cells, the oligopotent and the unipotent stem cells. But interestingly, the growth factors, the colony stimulating factors that we'll look at later, have their greatest effect on these cells, these precursor cells, which are capable of dividing but are not capable of going back to an earlier form. So this complete chart is something that you should know and know fairly well, and you should pay particular attention to the erythropoiesis, the formation of erythrocytes, and the leukopoiesis, but particularly the formation of the neutrophilic line. I'm not going to ask you to identify the eosinophils or basophils, monocytes, and I'm not even going to ask you to identify any of the precursor cells giving rise to megakaryocytes, but I will ask you to identify megakaryocytes, obviously. And I'm not going to ask you to identify any of the precursor cells in the lymphocyte cell line.